Hello and welcome to podcast number 22, continuing on with chapter 5, dealing with isomers. So again, isomers, same formula, but different position of atoms in space. We learned early on that there were conformational isomers, which have the exact same conductivity, but they rotate or twist to different positions, i.e. chair and Gaussian anti. We then went to structural isomers, also known as constitutional isomers, which literally have different conductivity. The groups are on different carbons within a backbone or different positions within a ring. And this time we're going to go into what's known as configurational isomers, hence the term absolute configuration. And the term chiral center I'm going to use loosely. I'm also going to use the term stereogenic center, stereogenic carbon, referring to a carbon that has asymmetry about it. By asymmetry, we mean that it has an imbalance. One side is different than the other. And so the easiest way for us to view this is going to be a carbon with 4 different substituents. And so basically what we're dealing with here, when you have these 4 different substituents, they can align on a central carbon or a central atom, but carbon, because we're dealing with OChem, is what we'll focus on, in a couple possible ways. Now, the easiest thing to do in our world is consider this right and left-handedness. And so that's what I'm going to call it initially. In fact, the names given to it are based on that terminology. So rectus, Latin for right. I'm going to use it to loosely say right-handed. It's not a direct translation, but close to it. And sinister, left, I'm going to say is left-handedness. And so these terms, rectus and sinister, R and S, as we'll shorten them to, describe the stereochemistry, the configurational stereochemistry around a carbon with 4 different substituents. Now, again, chirality can extend beyond just a carbon with 4 different stereocenters, or 4 different, substituents known as the stereocenter. But that's what we're going to focus on for now. And I'm going to consider mostly just one chiral center in a compound, but they can have a multitude. They have 2, 3, 4, a large amount. So to deal with this, the Kahn-Ingold-Prelog rules, some of the original rules, I guess brought up, almost 100 years ago almost? Not quite that far, but fairly long ago, they came up with this naming system, where you first prioritize the substituents that are attached to a carbon of a stereocenter, and you do it according to the atomic mass, the so-called A number. The reality is you're doing it more by the Z number than the A number, but they're going to work in unison. The reason we say atomic mass is because if you have 2 of the same element, but you have a different isotope, then you would take the higher mass isotope of the 2. So for instance, deuterium would get a higher priority over hydrogen. So technically, the definition is based on atomic mass, but you're going to see me use pretty much atomic number. And unless we're trying to distinguish one isotope from another, we're going to stick with that. Okay, so let's consider this central carbon right here. That carbon right there has 4 things attached. Priority according to mass would be 1 for iodine, 4 for hydrogen, but the key thing is of the atom directly bonded. So I want to hang on to that really I'm supposed to be looking at carbon and carbon. And this is going to become absolutely essential down the road. So 1 is iodine, definitely the heaviest. H is definitely forward, the lightest. But carbon and carbon have the same mass. And so that's where the rules get a little more convoluted. So carbon is the same as carbon. They didn't mention that one is an isotope of another. So we're a little bit at the mercy of just figuring out the way this thing works from the rest of the molecule. And so I go out from there. So I have H, H, and H as the 3 atoms attached. On this carbon, it's connected to an H and H, but also a C. Highest priority goes to C because carbon has a higher atomic mass, higher atomic number than any of these atoms. So this would be my 2nd priority. This would be my 3rd priority. I'm going to do this multiple times, so I'm going to keep on moving. You can stop, replay this, or you can hang on and have me do it a few more times in a slide coming up. But this is in essence what we're dealing with. So you have to figure out what the priority is of the 4 things attached. Okay, I'm going to click on, I'm just going to get rid of what I've written here. And so the rules from there, and again, I'll do examples, but I just want to list the rules as a guideline to start. You're going to orient the molecule in such a way that the lowest priority, number 4 priority, points behind the plane. So it's behind the plane of whatever we're looking at it on. So it's a substituent that points back. And then finally, with that aligned in that direction, you draw a circle, starting at substituent 1, priority number 1, and working your way around to 2, and then eventually 3. And if it's clockwise, we assign it R for rectus. And if it's counterclockwise, we assign it S for sinister. Okay, so that's the rule. And that's why a lot of O chemists will do this circle rule, counterclockwise and clockwise. So counterclockwise, clockwise. It'll make sense in a second, I hope, as we start doing examples. So like anything, definitions by themselves don't seem very clear until you see it applied. So let's go ahead and apply this. So I want to assign the priorities to 4 different groups in the following. So we're going to use, again, the Kahn-Ingold-Prelog system. And we're only looking at the 4 atoms directly attached. So notice before it said mass, now I switched to Z. The beauty of it is, unless we're dealing with isotopes, it's interchangeable. So I'm going to have a tendency to always go with Z. It's just easier to just look at the periodic table and decide what element number it is without going into mass. But technically, I should be being a little more specific about it. So I have on here a hydrogen, a chlorine, a fluorine, and a bromine. Okay, so within the periodic table, there it is. I see fluorine, check. I see chlorine, check, see bromine. Ah, darn it, no hydrogen, so I need to draw it in. And I'm hopeful that you have hydrogen memorized as element number 1. So again, I'm able to do this without invoking mass because there are no isotopes to deal with here. So starting with the lowest priority, I'm going to tell you H is number 4. Then going over here, fluorine is number 3. Chlorine is number 2. Bromine's number 1. In its reflection, bromine number 1, fluorine number 2, fluorine number 3, hydrogen number 4. So that's the first thing we do, assign the priorities. But then if you recall, we're supposed to align it so number 4 is in back, which this is true. Number 4 is behind the plane. This one, number 4 is behind the plane. So if I draw a circle from 1, 2 to 3 with H in back, this is counterclockwise, so it is an S chiral center. And this is 1, 2, 3, H in back, so that would be an R chiral center. It is, I want to be careful with this word, but it is as simple as that. But depending on how the structure is set up, it can go from a very simple system, because H is in back, to a far more complicated system. But in its simplest case, if number 4 is in back, you just simply draw the circle 1, 2 to 3, counterclockwise S, clockwise R. Okay, so I want to get this a little more complicated. So what I want to do is look at compounds that are a little more challenging. So you're hearing a pause in this because I am getting zapped by the Pepperdine internet connection. So if this recovers, this will be just dead space in the middle. It does not look like it is going to recover. You don't know this, but this is my 4th time recording this. Oh, there we go. I am going to, please forgive me, but I'm going to just fight on through this. So I completely apologize for this, but as you're hearing me complain already, this is the 4th time this has happened, and I'm just going to keep on going. Okay, so just to reiterate what we just did, priority number 1 was bromine, priority number 2, chlorine, priority number 3, fluorine, priority number 4, hydrogen. Clockwise is R, priority number 1, bromine, 2, chlorine, 3, fluorine, 4, hydrogen. So just basically repeating what we did, counterclockwise S. Okay, so now applied to completely new molecules. I apologize for the sudden shift of everything showing up at once, but I think the internet has finally caught up to us. And in doing so, everything got tossed out there. Okay, so on to this. I want to figure out what the priorities are, and then when I'm all done, I'll start looking at R and S. So on this carbon right here, I have an OH. I have one carbon, so a methyl. I have two carbons in ethyl. And what I'm not paying attention to is the fact that I have an H in back. So that would make this a chiral center right here. And I should probably draw my H in. Just be complete. And fortunately, H is in back, so it's going to make my life easier when I do the R and S. Priorities. Easiest priority is O is 1 and H is 4, but just like we ran into before, we have a problem with two carbons being equal. So this is the same thing we did earlier. Atomic number, highest for O, lowest for H, so priority 1 and priority 4 are easy in this example. But carbon and carbon are the same. So again, we must consider what atoms are attached. So just like we do in the game of war when we play, or the game of cards called War, when we play this game, you turn the cards if you're tied, which we are, we're tied carbon and carbon, you keep on going. So the best card this carbon can turn is H, because there's 3 H's. Whereas this carbon can turn an H, can turn an H, or it can turn another C. Because of the C, that makes it the second priority. So this carbon just became priority number 2. This one 3 because of that carbon right there. So bonds to carbon, H and H, beat bonds to H, H, and H. So carbon wins. Okay, to be complete then, I have a circle that'll go from 1, 2 to 3. That is clockwise, so that is an R center. Okay, next on the agenda, we have next compound down. Priorities, or the constituents are OH for 1, a carbon is part of a carbonyl or an aldehyde group 2, we have an alkene, but we also have a hydrogen that I need to write in again. So priority number 1 is going to be the O, just like before, and then priority number 4 is the H. So again, easy for those two. H and the heteroatom are usually pretty straightforward. But once again, I have the same situation before, a carbon and a carbon. So I have to compare them. This carbon on this side is bonded to a carbon and a carbon. So you count a double bond as 2 bonds to carbon. So this one has a carbon-carbon and an H. This carbon over here has an H, but an O and an O. So I would list this carbon here as being a carbon bonded to O, O, and H. O, O, H. And this one being bonded to carbon, carbon, and H. O wins, so that makes this the second priority, this the third. Clockwise again, so R again. And then finally, going to our last center. I'm going to put the H again in, if I remember it. Priority 1 is O, 4 is H, so again, this is the same tail. It happens often enough that this is actually pretty good practice to do over and over and over. So if you are sitting there trying to figure out which is which, priority-wise, hopefully you've already decided this one has an H, an H, and a C. This one, or I'm saying this one right here has a C, an H, and an H. This one right here has 2 bonds to C and 1 bond to H. So this carbon versus this carbon. And again, the one on the left, this one, is bonded to a carbon and 2 H's. This one's bonded to 2 carbons and an H. 2 carbons and an H wins. So 2 carbons beats 1 carbon. So that means this is priority number 2, this is 3. And I officially have no creativity because it was R, R, and R. Coincidental, not to say everything is always R. Okay, so we're getting a little bit better. We're doing a little more challenging ones in terms of priorities. But if you get your priorities down pat, and you need to get your priorities right, I guess is what I'm telling you, then these will become simple over time. But then we have complicated structures. So we're sticking with the simple. If number 4 is in back, you just take the arc as is. 1 to 2 to 3. In this case would be counterclockwise. Counterclockwise is S. That's a nice simple one. That's an S center, we're good to go. The first twist we're going to put on this, if H is in front, I want you to think about if you were looking at a clock. So if you're looking at a clock and the hands are turning from, let's say, 12 to 3 to 6 to 9 to 12, it'd be clockwise. But if you're looking at a clock backwards, then you would actually be looking at this. So forgive me for that. You would be looking at, oh boy, looking at this one. Oh, this is much harder than I thought it would be. That would be easy to do. So you'd be looking at 12, 3, 6, and 9 from the backside of a clock. So the clock would be going to 3 to 6 to 9. So from my perspective, it would be going counterclockwise. But if you were in front of it, you would see the normal 12 to 3 to 6 to 9 you're used to. It would be clockwise. So when you're behind, you see the opposite type of circle. So even though this is going clockwise, because number 4 is in front, I should be looking at it from the opposite side. Clockwise from the opposite side looks counterclockwise. So as a result, I have to reverse my clockwise, not clockwise, it's actually counterclockwise on the opposite side, so it's an S. So it's one extra layer of confusion, but still completely doable. So when 4 is in back, take it as is. When 4 is in front, reverse the circle you see. Okay, now want to introduce just kind of a twist on things. Let's go ahead and toss this one out. So again, the H is in front right there. So there's my H. So priority number 1, bromine. Priority number 4, hydrogen. Priority 2, the carbon with more attached. Priority number 3 there. So this is clockwise, but because H is in front, I'm going to reverse it to be an S. Okay, so let me get rid of my drawing and let the system's drawing kick in. So 1 and 4 easiest to get, 2 and 3 is such. So the view is from the opposite, then it's got to be the opposite. So even though I'm telling you, I'm drawing a, actually let me just do with purple. I'm drawing a clockwise circle. It should be actually counterclockwise because it should be from the backside that we're looking. Hopefully that's not too challenging. So in our summary, if it's in back, easy, draw the circle as is, take it as is. If it's in front, just reverse what you do, which means no increase in the level of difficulty of processing. But where it gets challenging is number 4 is in the plane. So number 4 can be in the plane a couple ways. So I'm going to just say, let's say it's here. Number 4 is in this position. Then I should be looking according to the rules that way. That's really hard. If you're good at drawing perspective, that's perfect. But it's kind of challenging to do. So if you do this, if you rotate this by 90 degrees, move this by 90 degrees, this 3 comes over here, this 2 will be pulled in front to where 3 is, and 4 will go in back. So I have a situation where 3 is in front on this side, 2 is moved to in front on this side, and number 4 is in back. And then I'm just going to rotate it up just a little so these end up in the plane. If I do that 1, 2, 3, and even then I don't have to. I can just do it like this. So as long as 4 is in the back, I'm good. So that's clockwise, that's R. If number 4 is here, same story. I want to rotate it to the back. So this arrow is I don't want to rotate it that far. I just want to rotate it just enough to get it back about 90 degrees. So if I draw my circle, 1, 2, 3, counterclockwise, so S. Okay, pretty straightforward. So if we consider this molecule, the priorities are 1 for chlorine, 2 for oxygen, and we run into the same problem where we get a 3 and a 4. So here, this is my priority number 4. So again, I should be looking down that bond. That's my perspective, but with a 1, 2, 3, 4, there's 1, there's 2, there's 3, and there's 4. So let me erase my numbering. So if I were to rotate this around, should be looking there. I'm going to rotate it around so that from that perspective, Cl is now on the right and up, OH is on the left and up, and this group is going down. So again, my priorities were 1, 2, 3. as already drawn. And then that arc is going that way. So counterclockwise. So this would be an S center for counterclockwise. If you're good at visualization, perfect. I'm going to try to come up with a slightly better way. Okay, so again, this is the way we just did it. 1, 2, 3, 4. There's a couple different things you can do. So the first thing, and I'm getting ahead of myself because it's going to pop up another slide, but anytime you change two groups, switch any two groups. So I'm going to say, let's switch this group and this group, trade them out. It ends up the center changes. So if I were to draw CL here, keep my OH in place, I didn't switch that one. Make this my methyl group, my CH3, and keep this. So priorities are still 1, 2, 3. Now this 4 is in back. This would be R. So that means if it's R after you switch two things, then the original one must be S. Anytime you change two substituents, any two groups, take whatever's in back, make it front, while making whatever's in front go to back, the chiral center will change. So I chose to put the one in back and number 4 in opposite places. So in other words, move number 4 to in back, and whatever's in back put with number 4. I change those two, I get an easy one to solve, R, and then I just switch it back. This method, a lot of people like when it's in the plane. Just switch it to and back, solve for the easy one, and then reverse it. Works beautifully. And then we're also going to do a couple other tricks, possibly. The way I'm supposed to do it, according to the book or the rules, is take number 4 and rotate it to and back, which would put 3 in front. So if I rotate it by 90 degrees, I have this, and now I can just do 1, 2, 3 for the S that I already knew it was from my previous approach. So again, it would be S. Okay, so just to revisit it, that's what we said in the last one, it's S. So the switch method, switch determined as R, switch back, and it was originally S. The rotate to and back, and up into this, the visual way that the book recommends, either of them work. Okay, we're gonna have one more method coming up, and it's an incredibly powerful method, and that is the why rotate things in your mind when you can move your hand. It is far easier to move your hand by 90 degrees than it is to change a visual in your mind or a drawing on a piece of paper by 90 degrees. So instead of looking with my eye, I'm going to now look with my thumb. So I'm going to make number 4 where I should be looking. Instead, I'm going to use my thumb, and I'm going to put all my fingers towards number 1. So I want you to just experiment with this. If you had your left hand doing it, put your left thumb up here. So literally touch your left thumb to the 4 and put your fingernails onto the 1. And if you did this with your left hand, you should be looking at your palm. Okay? If you did this with your right hand, put my right thumb here and put my fingers out this way, then I'd see the back of my hand. I would actually see my fingernails. So right and left hand, try these. Then if your right hand's there, curl your fingers and notice they will go back behind the page and hit the 2 before coming out to the 3. So a right hand would curl back. So let me try to emphasize that a right hand would curl back, hit the 2. That's the right hand. But if I did my left hand, again, my thumb here, my fingers here in the plane, if I curl it out, my left hand will go from here out the front through the 3 and then in back. So that's my left hand. So the correct arc would be 1 to 2 to 3, not 1, 3, 2. So left hand is wrong, right hand is correct. So for my right hand, it represents R. That's where the R comes from. So this is I think, easy method on the really challenging ones. So again, you can switch number 4 with whatever's in back like we just did. If we did that, made 4 here and 2 here, it'd be 1, 2, 3 counterclockwise, reverse it back, be clockwise and R. We can also do the thumb trick. I'm going to try to convince you the thumb trick is the best thing going. So I'm going to erase what I've written and let the pictures come in more cleanly. So start with your thumb this way, just like we said. And you already know the right answer is a right hand, so put your right thumb up here, the right finger's here, so you see your fingernails. Then curl it around. When you curl around, the fingers start to go back behind the page. They're going to eventually hit 2, and then when you crank your hand around, they'll come back out towards 3. So because it's a right hand, it is an R center. Let's try another one of those. Number 4 is in the plane, but pointed up. Or number 1's pointing up, number 4 is down here. So again, I want to start with my hand. I'm going to start with my left hand just because by default, that's the first one I put out there. It doesn't matter which one we start with because it only matters which one is correct. So if you choose your left hand and it's correct, it's S. If you choose your left hand and it's incorrect, it's got to be R. So if I started this way, my thumb would be here. My fingers, all my fingers would be pointed up. I'd be looking at the back of my hand. And when I curled in, I'd be curling in and coming down on 3. That's incorrect. So if I did my fingers here and my thumb here for a right hand, so if I did my right hand, now if I do that, I want to have my fingers up, my thumb out to the right. So I did that, I should be looking at my palm and it should look like an L. When I curl my fingers would come up. That was terrible drawing. Let me get rid of that. My fingers would come up and eventually hit the 2 before going back. So they pass through the 2 on the way out. So that would be right fingers, which would make this an R because a right hand fit it. Okay, this may not be as clear a picture as it could be, so I'm going to scale this up. So let me just go ahead and get all my writing out of the way and put this. So start with fingers towards 1, your thumb towards 4. You curl, notice that it comes out towards 2 before curling back towards 3. Right hand, so an R. So to convince you of this, because right now, if I was watching this, I'd say, thumb method looks crazy. I'm going to break my hand off. I just see the picture. It's dangerous. Your hand falls off. Doesn't work that way. It actually is a little bit faster on the right structures. So the switch method is nice if everything is done like this. In back, take as is. In front, reverse it. In the plane, but drawn in a simple structure like this, just switch it with the one in back, solve for it, and reverse the answer. That'll work. But where things get real funky and tricky is when you get into more complicated structures, such as a chair conformation. Not so easy to just cut this off. Now, you could, if you wanted to, just erase the rest of the structure. So I get rid of this and just do the left parallel center by itself. Get rid of everything else, so notice it erasing. That sounds great. That's a lot of work to do that twice. So that's not going to work. So instead, we're going to do the thumb method. I'm going to start with this center over here. Number 4 is coming out, or just going left, I should say, going on this back carbon. Number 1 is coming out. So try your hand. So if I put my hand this way, notice my thumb is here and my fingers are coming out. It's kind of awkward to see because it looks kind of like it's down and just it's not. It's kind of coming out. And so hopefully next picture will show a little bit more, but this way, just make sure this is correct. My thumb is pointing this way. My fingers are going here. Here's my palm. So this is my right hand. I'm going to curl, and when I curl, it's going to come up. I'm going to go to 2. So notice my fingers starting to curl up. So thumb towards 4, while make sure my hand is pointing the same way the whole time. Thumb is pointing this way. My fingers are curling up until finally curls up into 2 and starts coming back down to 3. This is a right hand, so this is right-handed stereochemistry. On the left carbon, I'm going to start with my thumb towards 4, my fingers towards 1. And again, I've chosen a right hand. Maybe it's correct, maybe it's not, but there's my right hand. Let's see how it goes. So as I do this, I'm going to curl my fingers and start curling back. And then eventually, they're going to get all the way. I have no idea why I decided to do that. So in this case, notice they started over here. They curled all the way back to 2 and out in front. This is a right hand. So again, a right-handed center. Okay, let's keep trying some of these. So for this priority here, let me make sure this is correct. This is priority 1, this O. This O is 2 because this O is connected to another carbon. This is just H, 3, and 4. So for this one, your thumb should be towards 4, your fingers towards 1. This is a tricky one. So there's 4, there's 3, there's 1, and there's 2. So I'm going to try my hand a couple ways. So I'm going to start first with the right hand just because it's there. I'm going to put my thumb towards 4, my fingers towards 1. And when I curl, they're going to curl down, which is moving away from the 2. That one's not going to work. So this time I'm going to use my left hand. With my left hand, I'm going to put my left thumb here, put my fingers this way. My palm's going to be pointed up. My fingers are going to curl up first. And when they curl up, they're going to hit the 2. They're going to come past the 2 and come back down to the 3. So my hand, when I have a left hand, is going to go from 1, fingers bend up to 2, and down to 3. So that would make this one a left-handed center. This one right here, priority number 4 is up, so that makes life easier. So 1 for the O, lots of carbons on this side, CH3 here for 3, and then H for 4. So 4 is H, 1 is O. The second priority, that's third priority. Thumb should be up, fingers towards 1, which means I'm looking at the palm of my right hand. I'm going to fold my fingers in, and they're going to come and hit the 2 before going back to the 3. So it's a right hand. It's going to curl correctly, giving me an R center. So I'm hopeful you see how easy this is when we get more complicated structures like a chair. With a chair, you can't easily trade things in and out. So pick the method of choice. H in back, take as is. H in front, reverse. H in the plane. If it's just a simple structure, then change the number 4 with the 1 in back, solve for that one, and then take the opposite. But when it's in chair conformation or Newman projection, it is way easier to just do the thumb method. So this front chiral center right here, that central carbon, is chiral, H, OH, CH3, and then the ethyl group in back. Priority number 1 would be OH. Priority number 4 is the OH. Again, the easy ones to get. Methyl is going to be 3 because it's just H's. The group in back is 2. So again, thumb towards 4, fingers towards 1. I'm going to choose a right hand just because first one I pick. I'm going to curl. Thumb towards 4, fingers up towards 1. When they curl, you're going to curl back. You're going to hit the cone carbon, excuse me, that was a weird statement. It's going to hit the 1 in back, the carbon in back, before coming over to 3. So right hand means this is an R center. This is a topic that comes with practice. The more you do, the better. I would recommend, if you like the hand method, try it on everything. It'll always work. About a third of the students, anytime I teach this, love the hand method. A third do the tricks, the crossing out, and the third end up in a splint because they injured their hand and they still have trouble visualizing, and they find a method. There's so many different ways to do this. So if none of the ones I presented are working, keep asking me different ways to do it, and eventually we'll get to a point that works for you. But I love the thumb method for the challenging ones, and I love the simple take it as is if it's in back, reverse if it's in front, and then if it's in the plane, switch it with whatever's back and take the opposite. I love that for simple structures, and I love the thumb method for more complex ones. So how do we use this in nomenclature? So I have a chiral alkane right here. So first thing, I need to get the chiral center. Priority number 1 is the longer chain. They're tied here and here. They're almost tied there and there, but this one wins because of the extra carbon over here. Methyl is 3, and H is in back is number 4. So priority 1, 2, 3, it is S. So you put the S in front of the overall name. So it is S hyphen 3 methylhexane. So carbon 1, 2, 3, 4, 5, 6. On carbon number 3, you have the substituent, and it's S. Had the CH3 been in back and the H in front, it would have been an R, 3-methylhexane. Okay, this next one, a little trickier because you have 2 chiral centers. You have 2 chiral centers, you have to worry about them both. So priority for the first one, H is coming out for the first chiral center. So priority 1 is this side of the ring, priority 2, priority 3 and number 4 and back. Looks clockwise, but because number 4 is in front, it's S. And then the other center, H is in back, so good, I'm gonna just take it as is, nice easy one. Priority number 1 is this carbon because it's tertiary. Priority 2 and 2, they're both secondary, but this one is part of a longer system. This one's lower priority. So this group is, H is 4, this is 3, this is 2, this is 1. Counterclockwise, so S. So it is going to be 1S, 2S, emphasizing their location. And I have to emphasize both of them. So it gets a little more complex. And if it's just one, like one chiral center, one substitution, or one substituted carbon, just simple. But here I had to go 1S, comma 2S. And then 1 ethyl, that's an ethyl group, dash 2 methyl, cyclo, 6 carbon, so hexane. A lot of work, but the chiral centers go in parentheses before you name the actual compound. You can do it casually. You're going to learn in your lab reports. We do it casually sometimes and how we name things, but technically it should be parentheses around the R and S. More than one chiral center, you have to specify where they're located, hyphen, first group, second group, and then whatever the ring system or linear system, whatever the rest of the molecule is. Okay, couple practice questions, and hopefully you'll have this wired. So put an asterisk next to each chiral carbon. Again, chiral carbon for a simple definition is something that has 4 different substituents. So nitrogen and nitrogen are out because they're not carbon. Carbon with a double bond O is sp2, sp2, sp2. They're planar, so they don't have 4 unique substituents, can't be chiral centers. Everything in this benzene ring, sp2, so it's out. This is CH3, this is a CH2, so they don't have 4 unique substituents. So the only one that looks to be chiral is this one. So I'm going to say that's chiral at first, but I need to double check. I need to double check to figure out what are the 4 different groups. So at first I'm going to say this is unique, this ethyl, and then a benzene. And I think the 2 sides are equal, or I mean unique, but let's see if they're equal. I go up here and get to a carbonyl. I go here and go to a carbonyl. So they're tied so far. So I'm going to go 1 away, go to nitrogen, 1 away from here, nitrogen with an NH. They're tied, and then I go and shoot, I get to the same carbon. Because of this plane of symmetry right here, it ends up, there is no chiral center. The 2 sides are equal. So dang it, this one was achiral. Well, that's a little tricky. So let me do the next one. Let me just jump to that in the first place. When I go to this carbon right here, this O and this, or carbonyl and this carbonyl are equal, this nitrogen and nitrogen, go to right there. Same thing, a plane of symmetry, so not a chiral center. I sure hope this next one is going to work out for me. So again, here's my carbon, I think. So same. Oh, different because of that CH3 right there. This is now 4 different substituents. So the one with the carbonyl is 1, 2, 3 for the carbon, and then 4 for the methyl. I don't know whether they're in or out because they didn't specify in the drawing, so I can't really tell you. But it's RS, but this is chiral. 4 unique substituents. Okay, feeling good about this. So a little more practice, because after all, that does make perfect. So assigning R and S, let's go relatively quickly on this first one. 4 and 1, so used to that. Long chain, gets a bromine. I'm tempted to make that 2, but this carbon right here is bonded to 2 more carbons. This is bonded to 2 H's and only 1 carbon. So this takes priority. So even though bromine is further down, this one wins on the second carbon, whereas this one loses. So this group wins right here and never makes it down to where bromine would have won if it made it. So priority 1, 2, 3. H is in back, so we take it as is. So we end up with an S chiral center. Ah, dang it. Bumped it, so hopefully it'll come in quickly. Perfection, huh? So once again, I should probably reiterate, these are first take videos with mistakes that happen, but you learn from mistakes. There's actually some very, very powerful learning that can occur from mistakes, and I'm justifying. Okay, so for this chiral center right here, H in front. I'm going to emphasize that's a CH3 now because I drew an atom here. I probably should balance it out there. Party number 1, benzene, 2, 3, and 4. So number 4 is in front. It's counterclockwise, but because 4 is in front, I reverse it and make it R. And the last one, kind of like this, looks a little tricky. I have this carbon right here. That's my chiral center. Attached to that, I will find something with an F, which makes it priority number 1, a nitrogen, priority number 2, a carbon with more bonds, a carbon 3, and then something with a bunch of H's. So now we have a situation where it's in a plane. So sure enough, we had all 3 cases: behind, in front, and in the plane. So again, I could, if I wanted to, redraw this as 4, 1, 3, and 2, meaning I switched 4 and 2. If I did that, this would be 1, 2, 3 counterclockwise S, which means by default that's R. That would work. Or I could put my thumb towards number 4, and with a right hand, so start with my thumb towards 4, my fingers pointing out of the plane but up. When I curl my fingers, I go back to 2 before coming down to 3 with a right hand, confirming this is R. Whatever method gets you the right answer is the best method for you. Don't be so proud you have to do it a certain way. Be flexible and try it different ways until you find the way that works for you. Okay, I'm going to end this at this point. Enantiomers we're going to pick up next. I made a comment in class, and that is when you look in the mirror, you know you're a chemistry person when you think, gosh, I have the same boiling point as my reflection. That's going to be our story here. Enantiomers, mirror images of one another, have the same physical properties. So that's knowing that now, that's why the other statement should have been funny. Have an absolutely wonderful day. Thank you for sticking through all this. And I'm going to end the recording and talk to you soon. Bye.